Hey, Year 11s, and welcome back. Now we're looking at question 2 from 2011's paper, and a special shout out for this one is going to Alice from St Andrews as well, because this question is about Alice. Okay, so I'll let you read through that, pause it if you need to, but otherwise we'll get on with it. But basically this first question is asking us to count up all of these and put them into our frequency table. And that's just a matter of counting. So we just have 6 A's, and we have 7 K's, 6 N's, and 6 R's. And bingo, you got some credit already. Okay, using her data, what is the probability of Alice getting a K on the next docket? Well, using her data, it's going to be 7 out of a total of 25. So that answer's fine. Also having a decimal there is fine as well, so 0.28 as an answer is perfectly good too. Okay, how valid is this probability, given at least, or give at least 2 statistical reasons for your answer? Well, to do this we need to think about a few things. All of these seem relatively the same apart from K, which is 7, so it's possibly not very reliable because we might expect those to be all the same and they're not. But really, if we think more about the context of what's written up here, she's just collecting them from ones that have been discarded, so that tells us something interesting. So how valid is this probability? Not really valid, we'll say. And let's get into that a bit more. So one of the reasons why it's not really valid is that she is sampling from dockets that have been discarded from or discarded by other customers. Not from actual dockets. So what we really mean here is it's possible that people take or rip off the letters that they want, and so she's not getting all the letters there. That's what that really means. Also, if we look at some of her data, we've got 2 K's there, 2 R's, 2 N's, 2 K's, 2 A's, 2 K's, 2 R's. There's a lot of pairs occurring there, and so that's something else as well. So we could say it appears data occurs in pairs, and what we'll say is data can occur in pairs. But since not all her data looks like this, customers have probably taken letters out already. Okay, now with this question, there is more you could say, and it is really up to what you see and just being able to articulate what you can do. But just getting down 2 or 3 points can really help. There's one other thing that I think I'll put down, and that's just about sample size. So sample size is too small for a reliable probability. So we really want to make sure that we're sampling more than 30 when we're running any kind of statistical measure. Okay, so there we go for that question. We'll continue on to question B. So question B, she's wondering about, on average, how many she'd have to collect to spell the word. And using her collection of dockets, how many dockets did Alice collect before she had the whole word of Ankara? Okay, so we want to count through until we've got all the letters we need. So I'll just spell it up here so I can cross it off. Ankara. Okay, so we've got an N first up. So there's the N. Got a K, so I can get rid of the K. Another K, so that doesn't do anything. An R, so that gets rid of the R. We've got an R. An N we've already got. A, so we can get rid of one of the A's. Another K, we've got K already. Another A, so we just need one more A, so we'll come along until we get the last A. There we go. So let's count up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that means that we need 13 cards before she can spell the word. Okay, so this next bit again, I'll let you pause there and read it if you want, but basically she's talking about getting an experiment here, and these are the results of her experiment. These are the numbers for each. So this first one here, 9 times it took before she could spell. This one it took 7, this one it took 8, and so on, with the longest here which took 22. Using Alice's data, give Alice an answer to a question. How many dockets would she have to collect on average? Give at least 2 averages. Well, look, we've got the mean average where we just add them all up and divide them by the total. That gives you 10.4, I think. I'll just check on that. Yep. You've also got the median. So the median for this one, the middle amount is 9. And you've also got the mode, which is 8. And that's answering the question because we've given those averages. Okay, explain which average you would suggest. Well, look, the one big problem we've got here is this massive outlier that's quite greatly affecting the mean. So I wouldn't choose the mean. That leaves the mode or the median. I think it'd be acceptable to use either, but I'm going to go with the median because it's really easy to justify. So I'm going to say median, since it won't be so influenced by the largest value of 16. Okay, it's not 16, it's 22. Alright. Alright, the supermarket says that each letter A, N, K, R is equally likely to be found. Why is Alice's experiment not valid? Well, if we go back to Alice's experiment, she's put the 6 letters onto a dice, and then she's rolled the dice, and whatever letter is on top, she's imagined that's the letter that she's found. Now the problem with this is that because there's only 4 letters to occur, and she's put A on 3 of the 6 sides, then A is going to be way more likely to come up. And so we'll just say here P of A equals 3 out of 6, P of N equals 1 out of 6, P of K equals 1 out of 6, and the probability of getting R is also 1 out of 6. And so we can see that A is 3 times as likely. So I'll write in a sentence explaining that. So we'll say we'll just read the question again. Equally likely to be found. So Alice's experiment is not valid because by using the dice, she has made A 3 times more likely to occur than any other letter. And also this contradicts what the supermarket said. So this contradicts what the supermarket says about there being equal numbers of each letter. Okay, and yeah, for that one it's really that simple, not very complicated. Okay, so let's just go over a quick summary of this second question. So back up to the top here. So for that first bit there, completing the table, that's really achieved there, so multistructural. And with the next question, that's also an achieved level question. Question 3, it's possible to achieve that from achieved level or merit or excellence level. And with question B, if you process that correctly, that's merit level, so relational. With the next part, working out the averages, that's relational or merit level. And the next statement is justifying what one you're going to use, that's relational as well. And then finally talking about why the dice isn't a good option. If you explain that properly, you're really looking at excellence, but if you're sort of halfway there, you're looking at merit. Okay, alright, and that's question 2 for